And welcome to another exciting video, and in this one we'll be covering monoids. So let's go ahead and consider a few examples over here. Let's say we're talking about addition. So if I add 0 to 1, the output is going to be 1. Similarly, if I add 2 plus 0, the output is going to be 2. In fact, if we have anything plus 0, we will get back that thing. So here we are getting 1, here we are getting 2. Remember, a semigroup is a type with a concat method. If this addition is our concatenation, we have a neutral element here. So 0 is the neutral element here that acts as an identity of sorts that gives us back our elements we are trying to concat with. If we have a special element like the 0 here under addition, we have what's called a monoid. That is a semigroup with a special element in there that acts like a neutral identity. So here, as you can see, we have this sum, and the sum has got this concat method where when we are concatenating a number over here, it's kind of adding it and then printing the result over here in the log. So here you can see it says sum of 2. Now let's go ahead and define an interface with this, and we will say sum is a monoid. If it has a concat method, that is, it is a semigroup and it has this empty function. So we can go ahead and write an empty function on this, like sum dot empty. Now sum has this empty function on it that will return us a special tag here, a special sum with the 0 here, a neutral element. Now here we can say sum dot empty. So I can write it now, sum dot empty dot concat, and I can go ahead and concat now this sum 1 and then the other sum that gets concatenated. And now if I go ahead and execute this, I'm getting the result as sum 2. That is, I'm getting the original element that I have concatenated it with. What we have done is we programmed an interface here with empty and concat, not special zeros and pluses. And that gave us our result, sum of 2. And it doesn't seem to matter that this empty is here at all because it's a neutral element. So taking this as an example, we can create monoids for different operations and sets based on our specific needs. Monoids are useful for composing and combining operations in a principled and predictable way. They can be used in various contexts, such as in the design of data structures, parsers, and other functional programming concepts.